Hey everyone, Chang here and welcome to my channel. For today's SAT, ACT, standardized test kind of prep video, I'm going to be focusing on polynomials in relation to inequalities. Now, rather than going through the normal level 1, level 2, level 3, level 4, so on with progressive difficulty, I want to break this down into different categories of problems. They are all very similar, but I'm hoping that by pointing out these minute differences, right, we can avoid some of the common mistakes that a lot of these problems are designed and hoping that test takers fall into. So there are three categories. It is not all encompassing in any way, but I'm hoping that it does cover a majority of the problems that you guys will end up seeing. So the first category is the most simple one. What is the solution? So what is the solution is, well, guess what? You are given a problem and you're going to solve it. So let's look at an example of what is the solution. Now for this first one, what is the solution? 3x squared minus 2 is less than x. Now, I love the first category of problems because guess what? They're going to list, multiple choice, all these different possibilities. Only one of them is going to be true, but it's not a trick question in any way, right? The one that's going to be true is going to be obviously true once you have solved this problem. The other one is going to be blatantly wrong. So those are the ones that are very easy, the ones that get you comfortable before the other two categories basically trick you. Now, in order to find a solution to this kind of problem, it's fairly simple. When you see something like this, inequality, 9 out of 10 times if you change it or think of it as an equal sign, you can practically solve it. Just don't forget the little nuances. So if we look at this, for example, and if we think of this as an equal sign instead of the less than sign, well, what would it look like? It would be 3x squared minus 2 is equal to x. Well, to solve this, minus x, I have 3x squared minus x minus 2 equals 0. So at this point, notice that it's just a simple quadratic. You can use the quadratic formula if you want to, or if you're accustomed or experienced and you can see how to factor it right away. This is, I believe, 3x plus 2 and x minus 1 equals 0. Let me, yeah, seems right. All right, cool. So there we go. That's how you would factor it in this. And then, of course, afterwards, you can solve it, right? X equals negative 2 over 3 or x equals 1. That's how you would solve this problem. This one is slightly different, but not that bad. We're still working with the fact that we're going to factor it all out. We're going to have a 3x plus 2, and then x minus 1 is less than 0 now. And, of course, that means x is somehow related to negative 2 over 3 and 1. So in this case, you can sort of plug in and test numbers to ensure that the final result is going to be less than 0. In other words, negative. That means if two numbers are multiplying each other to become negative, one has to be negative, one has to be positive. Well, since we're looking at negative 2 over 3 and 1, we just have to figure out where x belongs. Well, let's just test out a number. Let's just say 0. That's between these two. We put in 0, right? This is positive. This is negative. That will give you negative. So that's good. That means basically x has to be less than 1 and greater than negative 2 over 3. Or usually in parentheses notation, you have a negative 2 over 3, comma 1. And that's also very scary. So be very careful and be comfortable with this, because guess what? This looks like the notation of a point, but when we're talking about inequalities, this is drastically different. So be comfortable of these two possible formats. All right, so for our second category, which is the solution? Now, this is slightly different from the first category, what is the solution? And the reason for that is because guess what? This category scares the living daylights out of me. With the first category, it's very simple. It lulls you into this comfort. All right, the solution's either there or not, right? Once I figure out the solution, it's obvious that is it. I'm going to pick that and I'm going to get that problem correct. Now, the second one is slightly different. They will give you a bunch of different options, and each and every one of the options is a variation or shortened down a subset of the original solution or the all-encompassing solution. And that's what's scary, because guess what? They'll put all these different options, and what they want is for you to get the whole solution, every single part tested. And if you don't do that, then you're going to make a mistake because you pick one of the solution sets, and that's correct, right? But you missed out the other, so they're going to say that's still wrong anyway. So that's the common mistake that a lot of people encounter when encountering this second category. So here it is. We have a more complex polynomial. I factored it all out because I don't think it's the focus of this problem right now. Here's the different factors. So what we do afterwards is, of course, we figure out what numbers we were working with. We have a 1 and we have a 5 right here, and we have a -2. And of course, it's best to just reorganize it so it's easy to see, right? Just least to greatest. And then afterwards, you start plugging in numbers to test out, because guess what? These three factors, we want it so that it's greater than 0, meaning positive. So if we are able to test out with different numbers, we can see which area between these segments, right? Everything that is less than -2, everything between -2 and 1, everything between 1 and 5, and everything greater than 5, right? We want to see which one works so that this entire statement is true. Well, first and foremost, let's just see. Everything less than -2, pick the next smallest one, -3, right? And we plug it in. -3, this is still negative. This is negative. This is negative. So that's three negative numbers multiplying together, right? Well, guess what? Three numbers negative multiplying together is going to still be negative. So this doesn't work. Let's just say that doesn't work, right? Between these two right here, well, pick the easiest one, 0. That's negative, negative, positive. Well, negative times negative is positive. Positive times positive is positive. So it works right here. That's where x can be. And of course, we're going to test out here. Well, of course, between these two, just pick 2. Positive, negative, positive. So that's 2 positive, 1 negative. That doesn't work. And the last one, of course, right here is most likely going to be positive, but let's just test it out, right? Let's just say 6. Positive, positive, positive. Good. There it is. Okay, so x has to be in between -2 and 1 and everything greater than 5. Now let's just write this in parentheses notation. We're going to have -2, 1, union, so that's one notation you got to get used to, the union, right? It's saying that it's this solution set and one more. In this case, we're going to say 5, infinity. Okay, so that's the whole solution. If you see this as the option, then you're going to pick this. What's scary is that usually they'll do something like, okay, you have this, or you can choose this, or you can choose that. And of course, they need, I think, 4 or 5 different solutions, so they'll probably put something that really weird. That's, for example, negative infinity, -2. And then, or they put another union, right? Of course, they have their different ways of selecting possible solution. But remember that when you see this, you have to choose the one that covers all of it, not parts. Even though this is correct, it's the union of them, both of them, that makes this the whole solution. So be very careful of category 2. All right, so here we have our third category, right? How many solutions? Now, why the heck is this a category? Well, normally the problems you see wouldn't say how many solutions exactly. They would usually say how many, and they have a key word, or it's going to be phrased in a variation. But still, pay attention to the key word. The reason for that is because based on the key word, the number of actual possible solution is drastically different. So let's look at this for example. We can solve this. At this point, it's fairly simple, right? We can just write this as x squared minus 16x plus 48 is less than 0. And then we factor it out. That's x minus 12, x minus 4 is less than 0. So what are we working with? We have the number 4 from this one, and we have the number 12. And then we're going to have to test these three possibilities. Everything less than 4, everything between 4 and 12, and everything greater than 12. So everything less than 4, let's just put in 0. What happens? Well, that's negative. That's negative. Well, we want the end result to actually be less than 0. Two negatives multiplying together is positive, so this doesn't work. Pick a number between 4 and 12. Let's say 5, for example. That's going to be negative. That's going to be positive. That's good because guess what? A positive and negative multiplied together is going to, well, be negative. So we're good here. And the last one, of course, is to test out what happens here. Let's just say 13, for example. That's going to be positive. That's going to be positive. Doesn't work. Two positive numbers, not going to be negative. So there it is. Okay, so it's going to be between 4 and 12. Now, here's where it is. Sometimes they will say how many integer solutions, right? Integer solutions that actually work for this, basically, polynomial inequality. So here's the thing. Integer solution, then you're going to count, right? 5, 6, 7, 8, 9, 10, 11. That's 7 of them. But then they will also do other things. Let's just say, for example, how many even number solutions, right? Then you have to be very careful. You're looking at 6, 8, 10, right? That's 3. Or they would do something like odd. How many odd solutions are there? And then you're going to start counting, right? 5, 7, 9, 11. Of course, that makes sense because the total of these should be the number of integers. And lastly, they might do some weird trick question, like for example, how many real or how many solutions in general, right? Real or all solutions. And in that case, that's just infinite. And the reason for that is because guess what? All those numbers can be broken down to even smaller and smaller and smaller numbers, so you would have infinite solutions. So be very careful of keywords that they use when they ask for how many solutions. That's the one that trips a lot of people up. All right, so there you have it. That's 3 categories that I'm hoping covers a majority of the potential problems you will see in relation to polynomials and inequalities. Of course, the first category is the one that we always want. That's the what is the solution. It's either there or it's not there. The second one is the one that we have to be careful of because guess what? They're going to list variations of the solution. You have to pick the one that is completely written out, completely correct, right? And the third one is something like this right here that I just went over. And that's the one where they're asking for how many solutions. Pay attention to keywords, right? Integers, even, odd, real, and maybe they would throw in rational numbers, right? All mean slightly different things. So when they're asking for how many solutions, these keywords determine very different numbers. So hopefully you find this video helpful. If you haven't already, please like, comment, and subscribe. Go out there and kick these kind of problems behind because at this point, it should be fairly simple. Thank you for watching. See you in the next video.